선택적 2030의 대표이신 에드워드 마즈리아 교수님의 강연을 듣도록 하겠습니다. 강연 주제는 로드 투 지로입니다. 참고로 강연은 동시 통역으로 진행됩니다.
Thank you very much to the organizers for inviting me to speak today. We'll talk about green buildings and why the architecture and planning community worldwide is now probably the most important group on the planet that will be responsible for solving the climate problem. And I think you'll see why in the presentation. So we will begin the presentation. This is Toronto in North America and Canada in 1891. That's what Toronto looked like. Now, watch the building. Look at the building, the Flatiron building on the left. That's Toronto today. So how did we go from 1900s to today? What happened? That sold in 1927, 1930, and that's sold today. That's just one side of the river. And here we are where we are on the other side of the river. So how did Seoul go from before to today? This is Shanghai. In 1990, 25 years ago, that is Shanghai today, 25 years. So what happened? Why do we design like this today? Well, back at the turn of the century, 1900, the world was using coal for industrial production, and coal and housing and everything was all mixed in together. And it was a very, very dirty environment, and conditions were very, very bad at the time. The architecture and planning community got together in the early 1900s and formed an International Congress of Modern Architecture. These were the leading architects and planners and thinkers of the time. And they set out a list of guiding principles for reforming these bad conditions in architecture. And they laid out a series of principles. They call for function-based zoning. So the housing was in one place, and you took the factories and put them in another place, all the dirty industry outside the city. They call for high-rise housing to occupy the best land. Before, the housing was mixed in. It was not the best property. Now they wanted the housing people to come first. They called for housing in parks. So to put the housing in parks, high-rise blocks, make sure we space them far enough apart so every place had sunlight. And now we had the automobile, and so they called for free and efficient circulation to put the pedestrians and the people in one place and the traffic in another place. And Le Corbusier laid out his planned vision for the new modern city, high-rise housing blocks. You can see the cars and transportation on the lower level, people on the upper level, so to separate everybody, and big apartment blocks and commercial buildings. And Le Corbusier also laid out a new way to design buildings. He had 5 points. I'll show you the 4 main points. He called for column wall separation, no more bearing walls. Now columns and beams, and we can hang the walls off of the columns and beams. And what that led to was now we just had columns inside, so we can design anything inside the building. We didn't have structural wall. And it freed up the design of the facade because we can hang it, we can do whatever we want with the facade. And he called for horizontal windows, and you see that now everywhere. So this was one of the first, earliest modern buildings, and here you can see the structure is now inside the building in columns, and the wall is hung from the structure. So now we can have all glass walls. And so we went from this, in the 1950s we designed the skyscraper, the structure is inside, the glass walls now hung off the structure, and Mazria was the first full master plan for a whole city based on the modern principles. But modernism was only possible because of very inexpensive fossil fuels, so that we could heat, light, and cool all this space with very, very thin walls, and we can overcome the outside environment, the harsh conditions. Now we can control the interior environment with fossil fuels. But today we have a problem, a big problem. By 2030, between now and 2030, the next 15 years, 15 to 20 years, we will build 800 billion square meters of building, of new building, and tear down and rebuild. So how much building is 800 billion square meters? That's a building area equal to 60% of all the buildings in the world today. We will tear down a lot of them and build new and add buildings to that. A huge amount of building going on in the next 15 years. Or it's like building a new soul, entire soul, every 60 days. That's how much construction we're doing in the world today. If we don't get it right, then we will lock in energy and emissions patterns for 80 to 120 years from what we designed during this period. So we have a huge opportunity. If we do it right, we solve the climate crisis. If we don't do it right, there's no way we can solve the problem, because now we have all this building all in place, and we're not going to tear it down. So the world now understands that it's the architecture and planning and design community that must help us solve the climate problem. The UN is setting aside an entire day in December at the Paris conference, the COP21, just for buildings. They call it Buildings Day, to recognize the importance of the architecture and planning community in solving the problem. Why are we so important? Why is the world looking to us? Because urban environments are responsible for 75% of all greenhouse gas emissions. And in order to stay under 2 degrees Celsius warming of the planet, the scientific community has established that as a limit, because if we go past that, I'll show you in a minute, the planet keeps on warming, it becomes irreversible. In order to stay under 2 degrees centigrade Celsius, we have to phase out all carbon emissions in the built environment by 2050. That means Seoul would need to operate on all renewable energy, efficiency to drive down the amount of energy, and then renewables to phase in. Seoul and every other city in the world. This is the IPCC scenarios. They ran 4 scenarios of burning fossil fuels. And the first 3 scenarios, in blue and up in yellow and red, all go past 2 degrees Celsius. The only scenario where we can stay under 2 degrees Celsius is the what's called RCP 2.6. We peak around 2020 and phase out all carbon emissions by about 27. But that only gives us a 66% chance of staying under 2 degrees C. So they ran another scenario, and that is peaking next year, and then phasing out all CO2 emissions by 2050. And if we do that, we have an 85% or better chance of staying under 2 degrees Celsius. Why is that important? Because the other 3 scenarios, the planet goes past 2 degrees Celsius around 2050, 2060, and then it keeps on warming. There's no way to stop the warming because there's so much CO2 in the atmosphere. If we phase out CO2 emissions by 2050, then the planet doesn't reach 2 degrees C and then starts to come back to the climate that we've always known. Who is the head of the new, who is the new head of the IPCC? Mr. Lee from Korea was just named the new head of the IPCC. So Korea plays a very, very influential and important role in the world today. In 2003, Architecture 2030, our research organization, discovered that architecture and buildings were responsible in the US for about 50% of all energy consumption and greenhouse gas emissions. That's building operations was the big piece, but then building the building, making the materials and building the buildings was also a percentage. Combined, about half. Worldwide, it's about 40%. It is the biggest piece of emissions. And if we throw in the planners who plan how we plan our cities and developments, then it's 75%. In 2006, we formed an organization, a research and planning organization called Architecture 2030. It's a nonprofit organization that does studies and research and develops programs for reducing energy consumption and emissions in the built environment. And in 2006, we issued the 2030 Challenge targets for architects and designers all over the world. And we said that if you're going to design a building today, in order to stay under 2 degrees Celsius, you need to design to a 70% reduction below the average buildings. Your building needs to be 70% more efficient, less fossil fuels. And then 30% can be fossil fuels. But in 2020, that number goes to 80%. In 2025, 90%. And in 2030, all new buildings, major renovations, must be carbon neutral, meaning they use no fossil fuel energy to operate. That doesn't mean they don't use energy. They'll use renewable energy, either on site or purchased from the utility. But in order to stay under 2 degrees Celsius, this is what we need to do. So how do we get to carbon neutral? Well, the most cost-effective way is through design. This doesn't cost anything. What kind of form is the building? Orientation. What kind of color of the building is actually very important. What about shading, so we don't need much air conditioning? Passive heating, passive cooling strategies, natural ventilation, daylight. All commercial buildings are day-use facilities. We daylight them, we eliminate much of the lighting though. So all these strategies are very cost effective. Cost nothing in many cases, and it even saves our clients money. It's just information, how we design, how much we know how to design these buildings. And then the rest, we need to make up solar hot water, solar photovoltaics, wind, biomass, all sorts of renewables. We can then either import and purchase or produce them on site if we have enough area. If we don't, then we need to import. We also have a building stock that we need to renovate. So we're asking all developed countries to renovate between 2 and 3% of their building stock every year to a 50% reduction below what they're using now. About 2 to 3%. And we're asking developing countries to renovate their building stock 1.5 to 2%, down to 50%. So when you renovate, you make it more efficient. If we do that, new buildings are very, very efficient, high performance, carbon neutral by 2030. We renovate our existing building stock as a percentage every year. Then this is what happens. That's 2005 on the left. That's 2016 today. That's end of this year. And this is the roadmap that we developed for the UN. This is energy consumption in the world today. In the gray is fossil fuels. Above is renewable energy, clean energy. So we're going up. If we adopt the program that we laid out, then this is what happens. We reduce the energy consumption needed, for buildings by about 1.25%, 1.25% a year. That doesn't mean we don't need energy, we need energy. But the top part is already renewables that we have. And if we double that and supply the building sector with more renewables, double what we have now in the world today, between now and 2050, then we phase out all CO2 emissions in the building market. So how are we going to do this? It's a big question. We're going to need three things. Leadership, the people who are up here receiving awards for green buildings, they're the leaders. And we need more leaders. We need to show how to do it. And we're going to need stronger building codes that come in over time. And then we need the right information and tools to be able to design the carbon neutral standards. If we have those three things, we make it. If we don't do this, we don't make it as a plan. So first, leadership. Since we issued the 2030 targets, the 60, 70, 80 to carbon neutral, 90 carbon neutral, in 2006, 70% of the top 20 architecture engineering firms based in the U.S. have adopted the 2030 targets and are designing to those targets. They don't meet it every time, but they're working to meet the target. Very serious. Very seriously doing this. 54% of all AE firms in the U.S., of all firms, are designing to the targets now. 63% of all firms in the US think that they could get to carbon neutral, meet carbon neutral by 2030. 5 years ago, it was maybe 5–10%. Now, we know more how to do it, and everybody is now trying to do it. The US federal government has mandated all federal buildings must be zero fossil fuel use by 2030. Today, 65% reduction. All federal contracts and buildings. The state of California, by code, by 2020, all new residential buildings will need to be zero net energy. Essentially, net zero fossil fuels. Zero fossil fuels. You will not be able to build or design a building if you're an architect in California, a residential building, in 2020 unless it's zero net energy. By 2030, all new commercial buildings will need to be net zero. The code is getting more stricter every 3 years in California. And many U.S. cities, states, and counties have adopted the 2030 targets. So the country is moving in that direction very, very quickly. 325 architecture firms have committed to benchmark their projects, design to the benchmark, and then submit the data to the American Institute of Architects and publish the data on their building. So reporting the data becomes really important so we can see how we're doing in the U.S. So this is how we're doing in the U.S. On the left is 2005, the year 2005. That's energy consumption. In quadrillion BTUs, could be any. In 2005, the building sector was using 40 quads of energy. That's how much energy the whole building sector in the U.S. used. And in 2005, the Department of Energy, Energy Information Administration, said they projected that by 2030, we would need 43% more energy for the building sector because we would be adding more buildings in the U.S. In 2007, the projection came down. We actually didn't use that way. In 2009, 2011, 2013, the big jump 2007 to 2009 is part of that's the recession. But after that, the recession is in the models. So all the rest is efficiency gains in design. So today, we actually use less energy in the building sector in the U.S. today than we did in 2005. And we've added over 20 billion square feet of building in the U.S. through our building stock. So we have a larger building stock, we're designing better buildings, and we're renovating down according to the 2 to 3%. So essentially, business as usual, we won't even get back to where we were in 2005 until 2030. But we're now designing better, and the architecture community has now agreed to design better, and so we're on a much lower track. We have saved our clients, people who live in the buildings, and the people who own buildings, we have saved them already $560 billion in energy costs, and we're projected to save them over $5 or $6 trillion in what they were projected to pay in 2005, which they're not going to pay now. This is a huge amount of money that's saved. And now we have cities all over the world pledging to go to 80% reduction in emissions by 2050 or zero emissions by 2050. 80 by 50 or 0 by 2050. And these are cities all over the world have pledged to the Carbon Neutral Cities Alliance. So Seoul issued its emissions reduction target, 25% by 2020 and a 40% reduction by 2030. This is right on target for an 80 to 0 emissions reduction by 2050. Now, not only is the head of the IPCC from Korea now, but the head of Italy is now the president of 1,200 cities worldwide. So now Korea, again, is in a leadership position with cities all over the world. We're going to gather in Paris in December to make commitments. So since Mayor Park, I don't think he's here today, but I'll talk to him tomorrow, we will ask him to make a commitment to show leadership from Korea and call for an 80% to 0 emissions reduction for Seoul by the year 2050 and begin to put the programs in place to do that. That will show real leadership on the part of the government in the city of Seoul. So, how do we get to 80 by 50 or 0 by 50? Well, we need building codes. So we developed the Urban Climate Initiative. New York City has adopted this initiative. And what we do is we have a scale in the U.S. Our current building codes in the U.S. give us about a 50% reduction below roughly the average for each building type in the U.S. So if we design to code to them, we will roughly reduce emissions by about 50% and energy consumption. So we say by 2020, we want a 70% code reduction to implement that code in New York City and other cities, all the cities that are going 80 by 50. We say in 2025, we want an 85% reduction in code, and by 2030, the code should be 0 net energy. And the code would apply to all new buildings, to big building renovations, but also to building purchases at sale. So that if you buy a building, you have enough money to renovate the building. The building purchasers are the ones who have the money and go get the financing. And it's easier for them to renovate. And so we say a building purchase, an all building purchase, that you should meet the current code standard if your building doesn't. And then we say that in 2016, the 70% reduction code and the 85% reduction code ought to be what we call stretch codes. Meaning, if you want to meet a better code standard, we will give you all sorts of money and tax reductions, and so that you do better, so that we get more buildings out there that do better than the code. So that by 2020, then it's the 70% code. We have enough 70% buildings out there, so we know how to do it. And then the 85% and the Z&E becomes the code. In 2025, then we have the 85% code, and the Z&E code is the voluntary code. Give all the incentives, and then in 2030, we're Z&E code. So what would that look like in Korea? How would we do here? Well, you have a system, an energy efficient rating system. And today for commercial buildings, you're between 260 and 320. kilowatt hours per square meter. So that's what you're designing to today. So we say by 2020, put in place a new code, that's 140 to 200 kilowatt hours per square meter. By 2025, 80 or less. And then by 2030, a Z&E code. So in 2015, the 140 to 200 becomes the voluntary stretch code with all the incentives. And then in 2020, the 140 to 200 becomes the code, and the stretch code is 80 or less, and we get money and incentives, tax incentives, and low interest loans if you meet the more lower target, and then in 2025 it's the 80, and then the Z&E becomes the stretch code. So that by 2030, all buildings in Seoul would be designed with zero net energy standards and zero emissions standards. Well, okay. Well, so now how do we do this? What are the tools necessary to do this? How do we get the carbon neutral design, or Z&E, zero net energy, the same? It's a two-step process. Step one is information. We need the design information, the right information and the tools. And then the second is we need the technology. So what do we mean by information? Information is design and information. How do we design these buildings? What are the guiding principles? Just like in the modern movement, what are the guiding principles that are going to transform us to the new environment? That will get us, we can get 70, 80% out just through design. Everything from development strategies, walkable communities, transit development, how we design our buildings, what kind of materials we use, building elements, all of that we have to relearn and know how to do now will get us a 70 to 80% reduction, something we call the no-cost or low-cost option. First, that's the first thing we do. We don't go out and spend lots of money. We give our client value in design. We become the most important players in the world in reducing emissions. And again, if we don't do it, it can't get done. It's impossible. Only the architecture and planning community can get the reductions that we need to stay under 2 degrees Celsius. Make no mistake, and the UN is finally understanding that. They never really understood what we do. Very few people understand what we do and why we're so important. But now they understand. We've taken that message, and other architects have taken that message to the UN and said, this is how we're going to do it. And then we need the technology. That gets us another 20 to 30% because all buildings need energy to operate. But we reduce the energy consumption so we can phase in the renewables to take over from fossil fuels. And that's everything from site, solar, hot water, to utility scale, PV and wind, biomass, and hydrogen. All of those will then supply what the building sector needs if we do our job correctly. So let's talk about information, tools, and education. We have a problem. The tools now are very highly technical, they're very difficult to use, and in many cases, you need another expert, 2 or 3 experts to tell us how to design. By the time we design something and give it to the expert, the design is already done. And so they come back and say, you have a bad building. And we say, well, can you make it better for us? That's not the way to do it. We need the design information and the tools We need real-time simulation so that every time we draw something, it tells us if we're doing better or worse. Not later on when we give it to some expert. So, we're working with Sapphire, who has now, is on the market, real-time simulation for SketchUp and for Autodesk Revit. Meaning, if you're designing in Revit or if you're designing in SketchUp, I'll show you in a minute how that works. There's a dashboard, that's a part of it. We're working with Autodesk on Greenbuilding Studio for real-time simulation. We issued the 2030 palette that gives you all the guidelines, the rules of thumb that you can use when designing a building. We're working with the AIA. We have education programs to teach architects how to use all this and how to do all this. And we have the commitment, architects now committing, the large firms now have people that know how to do this now and are beginning to do this, produce the building. So the first thing, the 2030 palette. It's a set of guidelines. Everything from large-scale guidelines, from region, city, town, all the way down to site and building. And every issue in architecture has a guideline that's site, that's location specific. So it'd be specific for Korea. And it's a shared vision, a new global vision for how we should design. Similar to what the modernists did, this is a new vision. And it's everything from regional issues, like living shorelines and habitat corridors, to city-town issues, urban infill, to site issues, sustainable sites, to building issues, daylighting, heating, natural cooling, natural ventilation, night vent cooling, all sorts of different strategies, shading strategies, guidelines for all of these strategies. It's a new language for architecture and planning. And we're working with Sapphire now. They have a dashboard, and the dashboard goes up and down. If you're below the pad mark, and that's the 2030 challenge target right there. If you're below in your design, it stays in the green. If you go above, it goes red. So as I'm designing, that's going up and down, up and down. If it goes up, bad decision. If it goes down, good decision. It's like a computer game. But everything we do then tells us how we're doing. Okay? By 2030, we need to get to zero. So this now is on the market, new. And they'll actually show us how we're doing daylight, what spaces are daylit and what aren't, so we can refine the design instantly, in real time. And in Greenbuilding Studio, as you're designing, it will pull up the information from the 2030 palette of the things that you need to look at in order to get your design ready. So we're working with both developers. And then we're teaching the architects how to do this all over the U.S. We have 27 chapters of the American Institute of Architects teaching, training the architects on all the new information. And we have teachers who know how to do this. Just like in Korea, there are teachers that know how to do this. There are practitioners who know how to do it, people at the institutes, at the universities that know how to do this. And we need to enlist them to teach. And that's what we've done in the U.S. and in Canada. So yesterday, we signed the Memorandum of Understanding with the KGBC. We talked to the professional architecture community about running a series similar to that, taught by Koreans for Koreans, based on the guiding principles on how to design this new kind of architecture. And hopefully by March, April, we'll have the first sessions ready. We'll work with the people from the KGBC to get that ready. So I want to thank you for inviting me here. And good luck with your architecture, because the world is dependent upon it. And you have a big responsibility, because you have two of the most important global positions now in the world, and you need to show that leadership. Thank you. Take maybe 2 or 3 questions, maybe, for a minute or two. Everybody. It's a big responsibility. I know it's hard to digest all this. Oh, we have a mic.
I can say that. Thank you so much, Edward. Very exciting and very impressive. And how about the civil engineering? You talk about the architect, but I think that more valuable or the wide application for the infrastructure. So, what is your plan?
So at the 2030 AIA 2030 series that we run, the whole curriculum starts with infrastructure and planning, and we invite in our engineers to discuss that on how to do sustainable infrastructure and planning strategies. And then we move down through architecture and architecture products and building elements. So we cover in the course the entire thing. And now in the U.S. we're promoting what we call integrated design, so that the tools that we have to use, like Sapphire, the engineers, the architects, the planners, all input the same model in real time. So any decisions that are made, they all see it in real time and can then communicate with each other and change.
I suggest that the American Society of Civil Engineers and the Korean Society of Civil Engineers and some of the organizations are making the report card for the infrastructure, including the buildings. So I strongly recommend to use your system to put into the report card system. Then it's come true. Your dream comes true.
Thank you. Well, it has to be your dream too. Any other questions? Yes.
Thank you, Ed. Your presentation opens our eyes as to how architects can play a huge role to reduce CO2 emissions and help fight climate change. You're going to Paris in December, and you are one of the instrumental leaders who made Buildings Day, and now the United Nations of the world understand the importance of buildings and how it can reduce energy to zero net energy. When you go to Paris, how is Korea, looked upon? How are they performing vis-a-vis the reductions by the EU and other countries? Do you have any information on that?
Yes. Because I think previous to a few weeks ago, all the countries were putting in their targets, emissions reduction targets. And again, these are voluntary. So all the targets that different countries are pledging are voluntary, and then will be revisited every number of years to see where we are. So right now, globally, the targets pass us through the 2 degrees Celsius range. Some countries their targets are much better than other countries. I can show you what, we have a number of slides that show you where Korea is. This is the EU. The EU has pledged to be 40% below 2005 levels by 2030. The US has pledged to be 28% below 2005 levels by 2025. So 5 years sooner, hopefully, we'll be able to match the EU. But right now, we don't have a pledge. We do have the president has said an 80% reduction by 2050, but that's a long-range goal, and we don't have programs yet in place for that. So in the US, we're a little bit short, I think. Japan has pledged a 26% reduction by 2030. So that's 5 years after the US, about the same reduction. The US was 26 to 28%, so they're short. And they're considered not adequate. Korea pledged 37% below business as usual. So if this is where Korea is now, business as usual is just don't do anything. And so by 2030, it's way up here. So 30% from way up here is about 4.5% below 2005 levels. However, both Korea and Japan, part of that percentage, the 26% and the 37%, are buying international credits, meaning that they won't reduce the emissions in the country, but pay for another country who doesn't have to reduce their emissions, and, probably in the developing world, to reduce their emissions, and then Korea and Japan would take credit for that. If we take that out, so what's the actual reduction? In Japan, the actual reduction is about 16 to 20% below 2005 levels. And in Korea, the actual reduction is not a reduction, it's an increase of 12.8% in the country's emissions, but offsetting that with purchasing. Now, prior to a week or 2 weeks ago, well, nobody was looking at anybody very seriously. But now that Mr. Lee is the head of the International Panel on Climate Change and will be in Paris making speeches, this is not very good for him, I think. So I think my feeling is that now, given the importance of Korea now on the world stage as a leader, I think they will probably revisit the numbers and adjust the numbers between now and Paris. I think that will happen. I think it will have to happen because you have assumed a leadership role in the world on emissions reduction.
And then you say that you will get involved with the reductions, right?
Oh yeah, no, the reductions, everybody now realizes that all of the emissions are coming from our cities, on how we build our cities, how we design our cities, how we plan our cities, how we operate our cities, how we operate our buildings. And no matter what a country pledges, if the architecture and planning community don't start the revisions, then it won't happen. They just miss the targets. And then everybody's going to get very upset. And they'll get very upset at us because they'll say, why aren't you making the emissions? But one important note. Back in the Renaissance and during certain periods Korea and in China, the architects were looked upon as, on the social scale and the professional scale, as the leaders in the world. Very, very high status. And since that time, our status has been going down. And in the US, many architects were complaining. Well, the doctors, they look on the doctor, or the lawyer, or this, or that profession. And our profession now is laid down here. People don't know what we do, they don't respect us. Now, the architecture profession is above all professions in the world. Because now we're the only one that can solve this problem. And that's why the architecture community, when they know about the problem, steps up to the plate. Why? Because we're trained to make the world a better place. So why do the architects, when they hear about this, say, okay, we're going to do it? Because we're not trained to make the world a worse place. When we design to do better. And so when the architecture community globally, and in the US and in other countries, begin to hear about the issues, they begin to adopt the targets. Yaki Wo from Architecture 2030 and myself will be going to Shenyang tomorrow to sign a document. Yaki, you want to stand up? Yaki. Sign a document. 25 of the leading international firms, Gensler, Perkins & Will, Skidmore, Owings & Merrill, will all be in Shenyang. 25 of the international firms, and 28 of the most prestigious local design institutes in China will sign a memorandum, an accord, China Accord, pledging to design to carbon neutral or near carbon neutral standards today. As of tomorrow, after that, they pledge to begin to do it. And that signing will happen like the MOU with the HEC and the architecture community here. They will pledge to do that. That will have huge implications, I think, worldwide.
Thank you, Professor Edward Mazria. You really wake us up how important architectural law to reduce gas emission. But architects, including so many other areas, other industry, we have education program and practical and some manufacturer products and all the environment, everything is involved as part of architecture. We have to be overcome. Then do you have any specific strategy how we can integrate it with the other industry?
Yes. That's an excellent question. Because as we reduce the energy consumption of our buildings through design, the building products, and how you make the products, and all the industries involved. We make carpet, fabric, wood, the steel, concrete, steel, wiring, lights, glass, everything. Everything that's made in the world today, some products go in a building. So how are we going to change? Do we have any control over the whole industrial manufacturing processes? Yes. We have the most control than anyone. Why? Because we specify all the products that go into a building. In the US, we can actually call out products. So if we know that a manufacturer, somebody comes trying to sell us products, we say, what's the carbon emissions of your product? We want a product declaration, third-party verified. So it's good data. And he gives us the data, it's very low carbon, and I specify that product for carbon or for wood or for whatever. And I say I'm not going to specify other manufacturers. And if enough firms do that, enough architects do that, then all the manufacturers that manufacture that product type have to reduce their emissions in order to sell the product. Now I know in the US we get to select products, especially for private ones. In Korea, I understand you can only do can't specify a product, only put out the guidelines for what the product has to do. You can't actually specify product. But if someone comes to our office and says, I have carpet at the same price, but my carbon emissions are way down here, and you can specify that this is the performance criteria, and I'll supply it, and you specify that performance criteria, and they're the only ones, or one or two, can only meet that criteria, then every other carpet manufacturer, if there's enough architects doing it, will reduce the emissions of their product. So not only do we control how much energy a building uses to operate, we control what products a building is made of. And we can change the entire industrial sector of the world. Because if you're manufacturing glass, you know how much glass we use? Well, we have glass cups, we have glass wine glasses, we have, once they're producing low carbon glass for our buildings, then we'll produce low carbon for all the rest of the stuff. Because they will have already changed their manufacturing process. So, architects have huge power that they don't even know that they have. But now they're beginning to understand it. And the ones who step out in front will be the ones who get all the work. Thank you. Thank you very much.